Good morning, students. Let us continue where I left in the last lecture of photoelectric effect. This is photoelectric effect part 2. This is where we were. Conclusion was, if you have a potassium metal which has a work function of 2 eV, which means the amount of energy required just to move the electron from the potassium metal somewhere inside to the surface is 2 eV. So if you use different lights of the visible spectrum, it is found that when you use the red light, there is no electron emission because the energy of the photon of red light is much below the work function. So the electron cannot be excited out of the metal. Coming to the second, the orange light has a energy of the photon is 2 eV. In this case, the electron does move out but does not move ahead, which means it is on the surface, which means the energy of the photon of the orange light exactly matches with the work function. Hence, kinetic energy would be 0. Coming to the yellow light has got energy of the photon to be 2.25 electron volts because the frequency is increasing as I go from red to orange to yellow and so on. If frequency is increasing, the energy is also increasing. So the energy of the photon of the yellow light when hits the electron, part of it is used as a work function, the rest as a kinetic energy. Coming to the next. Moving on to the green light. The green colored light has a photon energy 2.3, which means out of which 2 is used for the work function, 0.3 for the kinetic energy. With the blue light, you have 2.8 as the energy of the photon. Required to move out is 2 electron volts, so the left is 0.8, which is used in kinetic energy. Coming to the last, the violet part of the visible spectrum, the energy of the photon is 3.1 electron volts, while you require 2 to move out, the rest 1.1 is for the kinetic energy. So when we talk about kinetic energy of photoelectrons, when I am talking about the kinetic energy of the photoelectrons, then the conclusion that we draw is for this particular violet light, the kinetic energy would be maximum, and then you would have for blue, then you would have for green light, and so on. Then you would have yellow, and here it is 0 for orange. So the kinetic energy is found to increase if directly proportional to the frequency of the hitting photon. Photon की frequency जैसे जैसे बढ़ेगी वैसे वैसे the kinetic energy would increase. Fine. Now coming to the second part of it. Talking about this particular diagram, have a close look. What have I done? I have again the metal is potassium with the work function of 2 eV, which means the amount of energy required just to push the electron on the surface from the inside is 2 eV. Moving on to the beginning of the experiment, I have used the red light. Wavelength ज़्यादा दिख रहा होगा. I have reduced the wavelength, reduced the wavelength, reduced the wavelength. Wavelength decreases as I go from red to orange to green to blue. Wavelength decreases, that means the frequency increases. That means the energy increases. Energy of the photon of red is 1.77 eV, photon of orange is 2, photon of green is 2.3, and the photon of blue is 2.8. Up. If I start putting a red light onto the metal surface, I find no photo emission. There is no kinetic energy, there is no electron emitted because the electron is not even moving out. For moving out, it requires an energy of 2 eV, which is also not available. So the electron is not even moving out. So I try to put a lot of red light. I try to increase brightness of the light, or I try to increase intensity of the light. When I try to increase the intensity, I am increasing number of photons. This should be clear. When you increase the brightness, more amount of light, more intensity, brighter light, which means you are increasing the number of photons. But there is no photoelectric effect. Why? Because each photon has only this much of energy. However, many photons may hit it, but the energy remains less. So the electron from the bulk is not able to move out because the work function is much more than the energy of the photon. So here you would have no photoelectric effect. Coming to the next. If I use the orange colored light now, When I use a faint orange colored light, what happens? The electron just moves out but does not move. I try to increase the intensity, matlab I try to put more light onto it. The electron again moves out because the energy is equal to the work function. So this electron then moves out, but there is no kinetic energy. The kinetic energy is zero. You may keep increasing the intensity, that will only allow the energy is only as much as the work function. So no kinetic energy. But if you take a mild green light, very less number of photons, even then there would be photoelectric effect. The reason is this energy is higher than work function. Since it is higher than work function, you require the work function, the electron reaches here, and the rest of it, 0.3, is used for the kinetic energy. While when I use a faint blue light, again the energy is greater than work function. So even if it is very less in intensity, but the frequency is higher, so I have increased the frequency and not the intensity. Even if you increase intensity, the number of photoelectrons will increase. If I increase the frequency as I go to blue, frequency बढ़ाने से the energy of the photon is 2.8. 2 has been used up to bring it here. Rest 0.8 will be used for kinetic energy. So here the kinetic energy would be maximum as compared to them. What happens if I increase the intensity here? If I increase the intensity here, then again I would have the electron moving up and it would be moving. So when you increase intensity, then it is directly proportional to the number. When you increase the intensity, then it is equal to directly proportional to the number of photoelectrons. But if you increase the frequency, then it is directly proportional to kinetic energy of photoelectrons. इंटेंसिटी बढ़ाने से अगर एमिशन ही नहीं हो रहा है तो नो फोटोइलेक्ट्रिक इफेक्ट. हियर if I increase the frequency as I go from green to blue, the kinetic energy is higher. As I go from orange to green, here the kinetic energy was 0, now it has a kinetic energy. So kinetic energy of photon depends upon the frequency, while the number of photons emitted depends upon the intensity, which is directly proportional to the number of photons. Kinetic frequency is directly proportional to energy of photon. Fine. So when you increase the intensity, it cannot cause photoelectric effect if the light is of a lower energy. Fine. Moving ahead to the numericals of this particular topic. Let us begin with the numericals and the physical aspect of it. We begin with this particular part first of all. The first part. Photoelectric effect, the energy of the photon, which the photoelectric effect, the energy of the photon which hits onto the metal surface is used for two functions. One is just to bring the electron onto the surface, and second to push it to move, that is the kinetic energy. Now, this photon ka energy can be calculated by h mu. H is the Planck's constant, mu is the frequency of the light that you have used. Work function is this. Kinetic energy is half me v square, where mass of the electron is 9.1 to 10 to the power minus 31 kg. V stands for velocity of the photoelectron. अगर ये ज़्यादा होगा, for the same metal, kinetic energy would increase as observed in this particular illustration. The maximum kinetic energy is for violet because the photon has the maximum energy. Fine. Now, to calculate h mu, what is h? The Planck's constant, 6.63 into 10 to the power minus 34 joule second. So this will give you the energy in joules. Work function is also calculated by h mu naught, where this mu naught refers to the threshold frequency. That is, it is the minimum frequency needed for electron of the metal to come to the surface of the metal. After that only can it move. So these are the terms that we require. Other than that, let us begin with the numerical part. That is the first numerical. Have a close look. A metal when exposed to light of 6000 Armstrong, okay, wavelength is given to you. The light exposed, that means photon का frequency निकाल सकते हैं because the wavelength is given to you. This can also be calculated by is equal to h c by lambda. So you can calculate the energy of the photon like this, or you can take it to this value also. Fine. Now we'll be focusing on to the numerical, everybody. So when we talk about the metal when exposed to the light of this much wavelength emitted electrons with zero velocity. Find the work function and the threshold frequency. Let us put the formula. Energy of the photon is equal to the work function plus half mass of electron v square. Now, in this formula, your velocity is given to be 0. Therefore, this part is equal to 0. Therefore, energy of the photon, that is h mu, is equal to the work function. So you can calculate the work function, or you can say the work function is equal to h c by lambda. Fine, lambda is given to you. Therefore, you can substitute the values. 6.63 10 to the power minus 34 joule second. C is equal to 3 into 10 to the power 8 meters per second divided by the wavelength. Wavelength has to be taken in meters, which would be your 6000 into 10 to the power minus 10 meters. So your meters gets cancelled, second gets cancelled, you end up in the answer in joules. Mind you, also the work function is equal to h mu naught, which means your energy of the photon is equal to work function, which is equal to h mu naught, which concludes that the frequency that you are going to calculate now is same as the threshold frequency, because the electron had a zero kinetic energy, which means photon का यहाँ से जो frequency आएगा, the same is the threshold frequency. So once you get the wavelength, which is this, you can calculate the frequency of the light. This is work function which we have done. This would be h. This is c by lambda, where lambda is 600 Armstrongs. So you can substitute c, which would be 3 into 10 to the power 8, and lambda would be 6000 into 10 to the power minus 10. And this is how you would calculate your threshold frequency. This time the threshold frequency would be same as that of the photon's frequency, because the energy of the photon is same as the work function, because the electron was moving with a zero velocity. Moving to the second question, and the last question that I am going to do is this. Pay attention, everybody. You are provided with a photon of wavelength 400 nanometers. Okay, that's your lambda. Hits a metal surface is hit, having a work function of 2.13 eV. Find the energy of the photon. Energy of the photon कैसे निकलेगी? h c by lambda करके निकल जाएगा. Done. Kinetic energy of emission कैसे निकलेगी? Half mass of electron into velocity square. ऐसे भी निकल सकती है. Velocity of photon ऐसे निकलेगी. Kinetic energy के लिए what you need is, you need energy of the photon minus the work function will give you the kinetic energy of the photoelectron. Fine. Let's begin. Now, the work function is given in 2.13 eV, can be changed into joules by multiplying it by the charge of electron, which is 1.6 10 to the power minus 90. So, I am finding the work function in joules the first thing, because I will be solving it in joules. So, your 2.13 is the work function. Change the work function into joules. You have to change 1 eV is equal to your 1.6 into 10 to the power minus 19 joules. So this you can use to convert your electron volt into joules. So once this is done, this work function of yours comes out to be 3.4 into 10 to the power minus 19 joules is your work function. So I have calculated the work function in joules. Now let's begin with the question. Energy of the photon. Energy of the photon is equal to h into c by lambda. Let's substitute the values. 6.63 into 10 to the power minus 34 into c ka value 3 into 10 to the power 8 meters per second upon the wavelength. Wavelength has to be taken in meters. This is nanometers. Nanometer is 10 to the power minus 9. So you get your answer in joules. On calculating this value, you would come up to 0.049 into 10 to the power minus 17. I am rewriting it as 4.9 into 10 to the power minus 19 joules is the energy of the photon. Done. So the first part, that is energy of the photon, is over. Okay. Now moving ahead, your energy of the photon is equal to work function plus kinetic energy. Therefore, energy of the photon, that is 4.9 10 to the power minus 19 में से work function को minus कर दो 3.4 10 to the power minus 19, तो you will get your kinetic energy. Is this clear? Energy of photon में से work function minus करो, you get your kinetic energy. Values, I have deliberately taken it to be 10 to the power minus 19 for easier calculation, because this was also 10 to the power minus 19. The value that you get is 1.5 into 10 to the power minus 19 is your kinetic energy of the photoelectrons. Done. Coming to the last part. This is your kinetic energy ka value. Done. Coming to the last, which is the velocity of the photoelectron. Now, to get the velocity, kinetic energy is equal to half mass of the electron velocity square. आपको velocity निकालना है. Kinetic energy is given to you. You've calculated it. Get it here. 1.5 into 10 to the power minus 19 gives you half. Mass of the electron is 9.1 into 10 to the power minus 31 v square. Under root करके you would get the value. Therefore, your v is equal to under root of 1.5 10 to the power minus 19 into 2 divided by 9.1 10 to the power minus 31, and you will get your velocity. With this, I come to the end of the topic, the closure of the topic of photoelectric effect. We've done 2 numericals. We've builded on the concept of photoelectric effect, and the main concept that we've done for the day was that intensity does not cause photoelectric effect. It is the frequency which causes the photoelectric effect. That is, if you increase the intensity, the number of photons will increase. And if the number of photons are increasing, your number of photoelectrons will increase if the energy is sufficient for them to cause the emission. But if you want the energy increased, you have to change the color of the light. अगर एक कलर की लाइट की इंटेंसिटी बढ़ाते रहेंगे, it will not cause the photoelectric effect. लेकिन अगर right amount of energy वाला light use करके, even if you use a faint green light or a faint blue light, then also you would get photoelectric effect. The kinetic energy of the photoelectron depends upon the energy of the photon which strikes the metal. कौन सा photon strike किया? Blue strike करता है तो kinetic energy ज़्यादा है, because the net amount left is 0.8 eV. Green strike करता है तो kinetic energy कम है, because for kinetic energy you are only left with 0.3 eV. Orange strike करता है तो there is zero kinetic energy, because the orange color that you have used has got energy of 2 eV. That is the requirement for work function. Fine. So the conclusion was, when you increase the brightness of the light, you increase its intensity. Only the number of photons increase. Energy of the photon does not increase. Each photon can only hit a single electron. Each photon can only cause the photoelectric effect of a particular electron. You cannot have 2 photons hitting the same electron. That is not how it works. It's a particle nature. एक बार hit हो गया तो electron कहीं और चला जाएगा. दूसरा फोटोन वहाँ नहीं हिट कर सकता है. Means you cannot have two photons hitting the same electron. Once the electron is hit, it changes its position, the second photon will not hit it there. Fine. With this, I close the lecture on photoelectric effect. Please watch the channel and the first part of the photoelectric effect to get this particular concept clear. Good day. Bless you all. Thanks a ton. Please share the video if you like it.